Hello, welcome to Project 2.5, the RPN Calculator. The RPN Calculator, or Reverse Polish Notation Calculator, allows the user to perform mathematical operations using a postfix environment. For example, 5 times 2. Postfix means the operators are entered after the operands. Before understanding how the calculator works, it's important to understand postfix notation, also known as reverse Polish notation or RPN. Unlike traditional math, which uses infix notation, where operators go between numbers, postfix notation places the operator after its operands. For example, instead of writing 5 plus 9, you would write 5 9 plus. At first, this might seem confusing, but it actually removes the need for brackets and order of operation rules, because the order is already built into the sequence. To better understand this, we can look at a binary expression tree. This tree represents the expression displayed on screen, 3 plus 5 plus 9 times 2. To convert this into postfix notation, we will follow a process called post-ordered traversal. This means we evaluate the left child of the tree, then the right side, and finally the root operator. This is the general rule for any tree presented within this giant tree. So first, we will take the left value, which is 3. Next, we move to the right subtree. Within this subtree, we evaluate 5 and 9. Then we apply addition, giving us 5 9 plus. Then we multiply that result by 2. So we add 2 multiply. Finally, we apply the addition at the root with a 3, giving us the full postfix expression, 3 5 9 plus 2 multiply plus. This order directly reflects how the calculation is performed, step by step. Postfix notation works especially well with a stacked data structure, where each number is pushed onto the stack, and when an operator is encountered, two top values are popped. The operation is then performed, and the result gets pushed back onto the stack. This is exactly how the ACES RPN calculator processes user input. So returning back to the physical calculator, we can now see how it actually operates using postfix notation. Instead of typing an entire expression at once, the calculator processes each input step by step. For this demonstration, I'll use the same expression as we saw earlier on the tree, 3 plus 5 plus 9 times 2. In postfix notation, as we derived, this becomes 3 5 9 plus 2 multiply plus. First, I press 3 and then enter it, pushing 3 onto the stack. Next, I enter 5 and press enter, and then 9, and then enter. Now the stack contains 3, 5, and 9. When I press the plus operator, the calculator pops the 9 and 5 from the stack and adds them, and then pushes the result, 14, onto the stack. Now I press 2, and then press enter. The stack now contains 3, 14, and 2. When I press multiply, the calculator pops 14 and 2, multiplies them, and then pushes 28. Finally, when I press plus, it pops 28 and 3, adds them, and then displays the final result, which is 31. This step-by-step process also shows how postfix notation works naturally with a stack. Each operation uses the most recent values, allowing the calculator to evaluate expressions without needing parentheses or order of operation rules. This is exactly how the RPN calculator processes user inputs. Furthermore, to prevent the user from interacting with the code in a way which is not intended, there are multiple error messages. For example, if the stack is empty and the user tries to perform an operation, the error message will appear. Additionally, since the stack variable is only assigned a bit integer, if the entered value is greater than 127 or smaller than negative 128, then it will not accept this value. Thank you for listening to my project on the RPN calculator. I hope you learned something about postfix notation and stacks. I hope you have a good day.